Well, hello everyone. Here we are now in part 2, and in this particular case, we're going to look at case 2, the persistent multiple actors. Before we begin, I would recommend that you watch the first video if you haven't already, which is where we discussed the singleton case. This is very important, especially because in that video, not only was the singleton case explained, but also the fundamental groundwork was laid for what we'll be using in this video, because this video is more of a continuation, as are the ones that will follow. Well then, we're going to use the same actor. We're going to use the very same interfaces and so on. So I recommend that if you haven't seen the last one, go watch it. Alright, what are we doing in this video? As you can see, the first thing you see is that it's a bit darker, mainly because of the actor we're going to create now. We are going to come over to BP and we are going to create an actor that is named Light Orb. We are going to go inside and we are going to create a BP Light Orb actor. Alright, it's going to have three simple components: a point light, then it's going to have a sphere collision. We're going to adjust the collisions on the sphere collision. I previously created a collision channel called Interact. How do you create a collision channel? You go to Edit, Project Settings, and within Project Settings, find Collision, then New Channel. You set the default response to Ignore, and here you name it Interact. You click Accept, and that's it. It will appear for you. Once you have created it, you will go to the actor, then select the sphere, and set its blocking to block all. For the collision enabled setting, you will set it to collision enabled. Sana, se, iyanenanane. The object type will remain exactly the same. All of this will also remain unchanged, and then we're going to add a sphere collision. Sorry, not a sphere collision, a static mesh, which will be a sphere. And this sphere, we won't touch its collisions or anything, but we'll change its size to 0.05, so it's visible, but so it doesn't bother us either. We're going to change the light's default color to red. Then we'll save that, and after that, we're going to come over here and say, alright, we need to interact with the light orb. So we're going to create here in the first person, we're going to create a blueprint interface. So we create it, we add interface, blueprint interface, and call it BPI interact. We open it and we'll create just one function, which we'll name. We click add function and type interact. We press enter, save, compile, and close it. If you notice some things are already made, it's because this is the second time I'm recording the video due to an issue with the first one. And so, once we have that all set up, we're going to come over here to the class settings and we're going to add the PPI interact, and we'll also be adding our PPI for save actor data. We are going to open up the save actor data, and then we are going to create a new function which will be called load light orb, and we're going to give it just one single input variable, and that variable will be light status. These variables är the last part, the one I will have to create a flip-flop out of the carousel step or file for the light state change. We're going to create it here. The vector is here, and then we'll add the interactive end. We're going to add a branch. And we're going to place it right over here. Alright, so we'll position it in this manner, and this particular component right here will function as a flip-flop. And the next step that we need to take is to add a point light right here, and then we will proceed to set its light color. We'll go ahead and connect that particular element right there. For this particular one, we are going to make it red by default. And for this particular one, we're gonna make it green. Yeah, right, we're all set. With this, we've now covered the fundamental aspects of this staging, and now obviously we're going to move on to the character, and then we'll generate an interaction graph. I'm going to input a specific key I have right here, which is AI interact, or basically, I just pressed the E key, and I believe, and then this gets executed. Well, from the starter, we're going to perform a line trace by channel. We're going to set up the camera, get actor. Oh, I mean, no, we need to get the world location. Perfect. And then here, what I do is place an arrow inside the camera, and we're going to get the location of this arrow. There we go. So at this point, we're going to create a branch. All right, so a quick break, and then right here, we're going to perform a sphere trace by channel. We'll connect the impact point right here, and then we'll set the radius value to 50.
We are going to create another branch here.
Note a break, and for the hit actor, we're going to set interact pass the message. I'll scale both of them down, and then we'll be all set. We are going to change the trace channel to interact for the sphere. In sphere trace by channel, we'll change the trace channel to interact, okay? So to pop, at that point, we would have everything ready. Let's go ahead and test this out on the map, which... Alright, before we do anything else, let's place the main actor. We're going to navigate to the light orb section, and then we'll add about 4 or 5 of them. Okay, that sounds absolutely perfect. Now, we're gonna come, and we're gonna use the E key. Perfect, we press it, it changes color. If I press it again, red, green, red, green. Perfect. We can see the actor is already performing well. Alright, so so now we are finally going to get started with the saving. As you can clearly see, our actor only has a single variable. Many people might be asking, why not just use a simple flip-flop? Which makes perfect sense. The problem with using a flip-flop is that clearly I don't have a variable to store the state. It's true, the flip-flop has an output, but eventually this could get complicated. Therefore, yeah, it's better to choose to do it this way. Well, or worst case, we could collapse this into a macro and we'd have 2 outputs, but well, it doesn't matter. Alright, once we have this, we're going to create the structure for this actor. We're going to call this structure fLightOrb. And it's only going to have a Boolean variable, which indicates the light's current status.
Alright, so we've got the light status right over there.
Alright, perfect. Perfect. Once we have that all set up, we're going to head over to the master data, and what we're going to do there is create a brand new variable. This variable is going to be called light orbs in plural, and its type will be an integer. And for this particular one, we're going to make sure that it is set up as a map. Now, we're going to add flight orb, and then we'll have in our master structure the variable for storing. Now let's head over to our safe actor. I'm going to close all of this because we won't be needing it for now. And we're going to go to our safe actor, the safe manager. Alright, what are we going to do in the safe manager? We're going to create 2 functions.
Light orb. Save. And light orb load.
Alright then, this is what we're going to do. We're going to connect the safe input right over here, and the corresponding load output will be placed down below. Alright, perfect. We'll go in there, and the very next thing that we're going to do is to fund the actors. I'm going to use get actor of class. In a real game, I wouldn't recommend it. But so the video doesn't get too long, I will use it. Well, ideally, what they would have to do is either cache the actors outside of this and simply loop here, or use soft references, or create an array type variable that holds actors and somehow obtain all those that have the interface and then find some way to filter them. There are many ways. In this tutorial, we're not going to get into that, and I'll do it quickly so it doesn't take too long, but this isn't the ideal method. Okay, we're going to take a break here, and what we'll do is hide the player, and then we'll add something here. We connect it up, and well, as you can clearly see, here we can execute the make command. And here we get the light status and connect it. But as we know, a map has a key and it has a value. We are missing the key. So where exactly do we need to place this key? Well, inside the light orb actor, we must create a new variable of the integer type and we will name it index. Now, what is the purpose of this? In order to differentiate the actors that we have on our map, to be able to change this value for each individual actor, you have to activate this little eye right here. We click on the eye and we can see that it has now become instance editable. We save and compile, and then we'll see that if we select it here on the map, on the side, we have index 0. Everyone has it at 0. But anyway, I'm gonna give each one a different index. 1, 2, 3. So then, okay, now 0, 1, 2, and 3. And now each one of these items has its own unique index. And when I come over to this point, I can then perform a get index operation. And I'll connect it right here. So now we have both the key and the value. Now we have to go to the load function where we're going to do the same thing, get the actor of class. Luminous orb.
For each loop,
we are going to add the break. And well, we've got this done. And now, instead of adding, we're going to implement a search. We'll use get index. We connect the index right here. And what's going to happen here? Well, though our actor is going to have to, in this part, search for the value that was saved, which we retrieved from master data. This here tells us if the key was found. Therefore, we need to add a branch. And if the branch condition turns out to be true, then at this specific point, we need to execute a load the light orb command. Hold on, that's not the way we want to do it. The load light orb should be handled as a message. Alright, I got the thought. I'm going to disconnect it from here. I'm going to connect the branch, and I'll connect this right there. Perfect. And from here, from this, which is this blue pin, I'm going to make a break. And I'm going to connect this right here. That's absolutely perfect. Now, the very last thing that we need to do, the final step, is to go to the actor, then navigate to the interface, and finally retrieve the load light orb event. We are going to connect the Boolean here, and from this point, the very next thing we need to do is call the interact event once more. So what we'll do is simply trigger interact, and this particular instance, we're going to use it without any message. And the reason for that is quite straightforward. We want it to call itself. Now, it should be all set. Alright, now we're going to press the play button. We're going to select an actor, for example, this one, and then we'll press 3 to save it. Then we'll go to Tools, to the TurboStruct database, and we're going to refresh it. And here, we can see that there are 4 elements stored. One is set to true, another is true, one is false, and the other is false. We're going to select 1 and 2, 0 and 1. So 0 and 1 are now set to true, and 2 and 3 are set to false. If I now press escape, and then I hit play once more, we can see it's like this. And when I press the button to load to 4, we see that okay, we see there's a small error, and that here we need to put a not Boolean. We're going to invert the state. Otherwise, when it arrives here, it's called in reverse. But as I mentioned, this is for the specific case. Each one, depending on how their actor or how their system functions, will have to implement some small different additional configuration. In my case, as we can see, I was missing the not here. So, if I now press the number 4, we can clearly see that the state is now being respected. We're going to change this particular one, and then we'll turn this one off. I'm going to save it now. I click to load it once again, and we see that we are right here, and the states are preserved. And also, if I refresh the database, you'll notice that the states are now properly interleaved. Alright then, that would be everything for part 2 on how to save and then load actors, of which there are many, so to speak. If I were to come now and do this to it, I would have to assign this one an index of 4.
Then I could come with this one and assign it index 5, and now we would have more actors. The problem with this, of course, is that when there are, say, 40 actors, it's not much of an issue because you're just changing an index. The thing is, when this scales up to, I don't know, 20,000 actors, it's clearly unfeasible to assign each little number one by one. In that case, it's essential to perform some kind of calculation, for example, within the constructor event, some calculation that it would not generate an index for you, for example, based on its position or its rotation. It would take into account the position and the rotation, and based on those factors, it would then create a unique ID. And well, in that specific scenario, yes, it would certainly be possible. The problem, of course, is that if we were to move the object even slightly, or if we were to modify its properties, that unique ID will inevitably be lost. That's why, as I've already mentioned, every specific scenario or application might require a completely different logic for generating these unique identifiers or indices. However, in this particular instance, given that it's merely a simple demonstration example, we'll simply maintain its current state for the time being. Alright then, in the very next section, we're going to be taking a look at the actors that are dynamically spawned during the actual execution time. So, well, I'll see you in that part.